Capabilities of the Cloudant NoSQL database. In this presentation, we will introduce the Cloudant NoSQL database and talk about its components and features. After the end of the presentation, you should understand the basics of Cloudant and how to use it. We'll cover the HTTP RESTful API, using secondary indexes in MapReduce, Cloudant Query, and Cloudant Sync. Cloudant is a NoSQL JSON document store that's optimized for handling tons of concurrent reads and writes, a workload that is typical of large global mobile app usage. You can use Cloudant as a fully managed database as a service running on public cloud platforms like Bluemix, Rackspace, Amazon AWS, and Azure. There's also an on-premise version of Cloudant Local that you can run yourself on any public or private cloud platform you choose. It's got a RESTful API, which makes it easy to access from any language or paths. What makes it really unique is its ability to spread your data out across data centers and devices to scale bigger and deliver data non-stop. All this makes Cloudant a great fit for large or fast-growing mobile, web, and IoT apps. Cloudant is a database service that grew out of a specific use case, the Large Hadron Collider, or LHC. The implementation provided a database backend for distributing petabytes of data from LHC to scientists distributed worldwide. The project was a success and grew into the Cloudant that we know today. The majority of Cloudant, its meat and bones, is built upon Apache CouchDB. It's used for JSON storage, Cloudant's RESTful API, and the multi-master data stores. This ensures full API compatibility with CouchDB. You can operate seamlessly between the two, including replication and sync. CouchDB was selected as Cloudant's backend because of the high value that CouchDB placed on data availability and data durability. Cloudant adds to this Dynamo-style core-based clustering and scaling framework for horizontal scaling, engineered Apache Lucene text indexing and search, GeoJSON for performing incredibly powerful geospatial queries and geoload balancing. Cloudant stores data as self-describing JSON documents. Cloudant's RESTful API makes every document in your Cloudant database accessible as JSON via a URL, making it programming language agnostic. This is one of the features that makes Cloudant so powerful for web and mobile applications. The Cloudant API is compatible with the Apache CouchDB project. You can leverage the abundance of CouchDB language libraries and other tools to help make application development easier and faster. The same applies for Cloudant's Lucene indexing, which is compatible with most anything that works with Lucene and Elasticsearch. Cloudant's geospatial indexing is compatible with GeoJSON and other GS standards. The Cloudant API can be divided into 5 areas. Traditional Create, Read, Update, Delete, or CRUD for managing the lifecycle of documents. The primary index, which allows you to find documents by their primary key. Secondary indexes, which returns a subset of data and/or provides aggregation. Cloudant Query, which is a declarative way to define and query indexes. And General Search. It's an enhanced search system based on Lucene for searching documents containing search keys. Because Cloudant uses consistent hashing, the _rev assigned to a document will be unique and is guaranteed not to generate a hashing conflict. The value _rev is prefixed with an integer, which reflects the number of revisions a document has received, followed by a hash of the contents of the document. Because the hash is determined by the contents, we say that the rev field is unique per document. Similarly, no 2 documents inside a database can have the same _ID value, so the ID field is unique per database. Cloudant recommends that users who programmatically assign custom ID fields to documents do so according to a naming convention that guarantees uniqueness. For example, appending a time or a date code following the unique document name. Cloudant's RESTful API makes every document in your Cloudant database accessible as JSON via a URL. This is one of the features that makes Cloudant so powerful for web applications. Each document in Cloudant has a unique ID field which can be used to retrieve it. To retrieve it via the API, simply append the document's ID to the URL of the database. For example, for a document of ID 100 in the author's database, the GET URL to retrieve the document would appear as shown. Documents can be inserted into Cloudant using POST or PUT. To insert documents, you have the option to provide a unique value for the _ID field. If the document to be inserted doesn't define an ID value, one gets assigned on insert. If you want to provide an ID and insert via post, then the ID must be in the document. Via a put, then the ID must be in the URL. If you define an ID for your document up front, you need to make sure that the ID isn't already in use. If it is, the insert will be assumed to be an update of an existing document. Updates are like inserts, where an ID is provided and that ID already exists in the database. Also, for the insert to succeed, you must provide the latest rev value for an update. If you update with the post, the ID must be in the document. If you update via a put, then the ID must be in the URL. A delete requires an ID and the latest _rev. If you use HTTP delete, then the ID and rev must be in the URL. If you use put, you place ID in the URL and rev and deleted true in the document. Secondary indexes or views are defined in a map function, which pulls out data from your documents and then can use an optional reduce function that aggregates the data emitted by the map. These functions are written in JavaScript and held in design documents, which are special documents in the database that hold secondary indexes as well as other features supporting the database. The naming convention for design documents ID begins with _design followed by / and then the name of the document. Let's look at an example from a car dealer inventory scenario. In this example, we're going to show you a map function that returns a list of car makes and their book values, and then a reduce function that returns the aggregated book value by make. Let's walk through the example. Here is our list of cars. Now let's build a map function that returns a set of key value pairs with the makes and their book values. Next, aggregate the book values by make with the reduce function. And this produces the results as shown for the map and the reduce. Cloudant query provides an alternative way to define and execute queries against documents. Instead of writing a JavaScript map reduce view, you define an index by posting a JSON body listing the fields you want to index. Continuing with the example from the previous slide, we could index the list of cars in an inventory by make with this JSON object. Once you've defined an index, you can run queries against it. A query is run by posting a JSON containing a selector object. If you know MongoDB query documents, this should look familiar, and can contain other optional parameters, fields, sort, and limit. This also gives database developers experience with the SQL select statement where clause, a familiar starting point. This example selector will return all documents with a make of VW and a model year of 2000 or later. There are two types of indexes, JSON and text. A JSON index is translated behind the scenes into a map-reduced secondary index. These can run faster, but sacrifice a bit of flexibility in supported selector types. Text indexes in Cloudant query are much more flexible. You can even define a generic catch-all text index across all the fields of the documents to get started, but you'll likely want to build specific indexes when optimizing for performance. For either type of index, for the best performance and predictable response times, you should create an index on every field that will be used in queries. For example, if you had a database containing documents of books in a library and you planned on making a query against author, title, and year published, you'd want to create an index with all three fields, rather than just create an index on the author field. Cloudant query gives you two API endpoints, one to manage indexes, _index, and one to execute queries against, _find. Managing user, machine, and environmental data for massive networks of mobile users or remote devices can be a scalability and availability nightmare. The problem is that most databases require updates to occur in a central master database. This can result in performance bottlenecks and also prevent client apps from running if the connection to the master database is unavailable. Cloudant Sync enables you to push database access to the farthest edge of the network, mobile devices, remote facilities, sensors, and internet-enabled goods so that you can scale bigger and enable client apps to continue running offline. Cloudant Sync allows mobile and distributed apps to scale by replicating and syncing data between multiple readable, writable copies of the data in other data centers and even on mobile iOS and Android devices. This is much easier and more cost-efficient than growing a single central database to handle all the data collection. Cloudant Sync simplifies large-scale mobile development by enabling you to create a single database for every user. You simply replicate and sync the copy of the database in Cloudant with a local copy on their phone or tablet or vehicle, sensor, appliance, etc. This can reduce round-trip database requests with the server. If there's no network connection, the app runs off the database on the device. When the network connection is restored, Cloudant resyncs the device and the server. Some of Cloudant's largest mobile developers have scaled into millions of databases with Cloudant Sync. On IBM Bluemix, Cloudant has two primary plans, the Lite plan and the Standard plan. The Lite plan is free and has limits on total data storage quantity and also throughput capacity. If you try to exceed these rates, the RESTful API will return HTTP 429 error codes, and your application will need to throttle requests. Services with the Lite plan can be removed after 30 days of inactivity. Generally, the Lite plan is fine for development scenarios, but for production applications that need to scale, a Standard plan is needed. It starts with a higher level of throughput capacity and can be adjusted upward in the service dashboard for even higher throughput as needed. In addition to these plans, there is also a dedicated hardware option which runs in any IBM Cloud data center and includes a HIPAA-compliant option in US data centers. This concludes our overview of the capabilities of Cloudant. Thanks for listening.